Hello students, welcome to this model number 5. Again, we are going to discuss in this chapter other materials and material selection. So we have to discuss about a very new topic, that is the uh, smart materials and its types, and in that one of the smart material, that is a piezoelectric material. So we'll discuss in detail. Okay. So first of all, what is meant by smart materials? We will understand. So these are all designed materials having one or more properties that can be significantly changed in a controlled fashion by means of external stimuli, such as stress, temperature, moisture, pH value, and even for the electric or magnetic fields. The change in properties is reversible and can be repeated any number of times. For example, a particular plastic material, which is an insulator at normal conditions, can be made to behave as a conductor by applying a compressive force. So upon removal of the force, the plastic material returns to its insulating states. A photosensitive glass darkens when exposed to the sunlight and returns back to its initial state when it is protected from the sunlight. So some of this material are going to be change color in response to change the electric stimulus. And similarly, there are a wide range of materials, each offering different properties under different circumstances. Such materials are designated as smart materials. So because of these reasons, response, they are produced to proportion to a stimulus acts as a feedback or signal. So following a decision to taken accordingly. For example, even for the aeroplane might be have wings made from a smart material that changes color as soon as tiny cracks starts to develop. Okay, so I wound dressing that changes its color when inflections develop, and also so on. So this all the smart materials have a potential to change engineering and technology and design principles completely. Okay, so what are those different types of materials we look at? First one is piezoelectric material, and second one is electro-rheostat and magneto-rheostat material, and quantum tunneling composite, and color change material, and shape memory overlay. So in this, for your knowledge, for your chapter of the semester, these are the only they have to we have to study in detail. Okay, so first begin with this piezoelectric material. Okay, these piezoelectric materials uh, have two unique properties. Okay, which are inherent when a piezoelectric material is deformed by applying stresses. Okay, these are the one kind of material. So you can see here, I have posted this presented this one of the piezoelectric material. So this gives off a small electric discharge alternately. When the electric current is passed through this piezoelectric material, it experiences and significant deformation. It is for this property, piezoelectric material are most widely used as a sensor in different environments. Okay, so common piezoelectric material includes ceramic material like lead zirconium titanate, or barium titanate, or lead zirconate titanate, or lead zirconate, okay, or potassium carbonate, or polymer material like polyvinyl fluoride. Or typical industrial applications of piezoelectric materials are we will discuss now. Suppose if you take for automotive industry, how it is going to be applicable for applications are used. So for automotive industry, the airbag sensor, airflow sensor, or audible alarm, or fuel atomizer, or keyless door entry, or seat belt buzzer, a knock sensor, like that, they are going to use for this automotive industry. And furthermore, application in field of computer industry used for the actuator for disk drives, dot matrix, or inkjet printing heads, etc. So for the consumer, so suppose it is used for the depth finders, fish finders, humidifiers, jewelry cleaners, musical instruments, speakers found in cell phones, and musical green cards, and telephone, and cigarette lighters. So these are all some of the applications used by the piezoelectric material. Even for the wide range of medical field also, it is used for the fetal heart monitor, ultrasonic imaging, ultrasonic contract removal devices, or uh, cochlear implant, etc. And even for the military, they are going to use depth sounders, guidance systems, hydrophones, and sonar. Okay, for the sonar, it is very important. Under the water, this has to be sense the distance, or identify this opposite trackers. So it is very helpful for in the case of military. So, and manufacturing. So for the manufacturing, it is used for actuators in ultrasonic cleaning, ultrasonic welding, motor in environment with strong magnetic fields or cryogenic temperatures. So what is this cryogenic temperature? Means where it is temperature below that for minus degree centigrade, means 0 degree centigrade. That is what we call as cryogenic temperatures. So these are all about the piezoelectric material applications. So let us discuss some other topics related to this piezoelectric materials or other applications. We'll discuss in the next video. Thank you.